How's it going, everyone? Today we're opening up PEP 767, which is all about giving us a single concise way to signal that an attribute should be read-only from the type checker's perspective. The proposal builds on PEP 705's qualifier and lets us decorate ordinary class attributes and protocol members, not just typed dictionary items. That means we can stop overloading final, hiding values behind properties, or freezing the entire class when we just want one field to behave as read-only. And only the type checker enforces read-only, not Python's runtime. So you can still mutate values if you really want to, but the hint makes it unmistakable when future attempts to assign or delete should be considered violations. Now, before we jump into the examples, I'd just like to thank Zed for sponsoring this video. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding for months now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get started by creating a plain class that wants a read-only identifier. And for the next few examples, I'm going to use the class var type, the protocol type, and the read-only type, which currently only works with type dictionaries. So right below, I'm going to create a class, and this class will have some red squiggly lines. Because as of Python 3.15 Alpha 6, this feature is still not available, which means it's not really going to be that useful just yet. Currently, PEP 767 is still in draft, which means hopefully it will come out in Python 3.15, but it might come out later. But all I want to say is that since this feature has not been released just yet, all the code you're about to see is hypothetical, and based on the documentation released in the PEP. So here we have a class called member, which is defined as read-only, of type integer. Later on, we assign the ID to self.id because of course we want to assign it a value for later. Now outside, I'm going to create my if name is equal to main check and paste in my main entry point. And then inside main, I'm going to create a member. And the first thing we do inside here is initialize the read-only ID attribute inside the class's own initializer. And we're doing that before this instant escapes into the wild. Next, we print the stable identifier so viewers can see what it is. The type checker would bark if we try to assign to member ID outside of initialization, even though Python doesn't stop us at runtime. That's the whole point of read-only. Protocols also get a major cleanup. Instead of forcing people to declare an abstract property method, we can now just say variable name of type read-only of whatever type you want to use. And structural typing understands we're not allowed to write to it. That makes the interface shorter and opens the door for descriptors, class variables, and plain attributes to all satisfy the contract. And class attributes get the same treatment when we combine read-only with class var. Assignments are only allowed inside the class body or in init subclass, which is exactly where read-only permits them. You can still override the class level value in a subclass, but the type checker will treat it as read-only once it's declared. So down below, we will print the default scheme before any subclass tweaks. And what you should notice is that the subclass evaluation path is the only legal place to mutate the class attribute once the declaration is finished. Now, when we run this, what we should get as an output is HTTPS for the default scheme, and for the FTP scheme, we will get FTP. And this was all legal. So read-only is no longer just for typed dictionary items. It now covers every attribute situation we care about, so we can write leaner, more intent-revealing classes and protocols. And the PEP considered a few rejected alternatives worth mentioning. An early draft restricted read-only attributes to assignments inside the init block, which is similar to C#'s approach. This turned out to be too restrictive. So the final version also permits dunder new, dunder init subclass, and add class method. Otherwise, it would be pretty painful to use in practice. Another idea was to allow bare read-only attributes with inferred types, but that ran into technical issues and awkward edge cases, so explicit annotations stayed. And I think this is probably the most reasonable solution. But that just about wraps it up. Read-only makes it crystal clear to both type checkers and future maintainers that an attribute is meant to be immutable. And I think I'll be reaching for it a lot. But once again, as of Python 3.15 Alpha 6, this feature is not yet available, so all the code I used in the video was based on the documentation. As soon as they release this feature, I'll make a much more in-depth video showcasing it, so we can see how it works in practice. But I'd really like to hear what you think about this upcoming feature in the comments section down below. What your thoughts are on it, whether you think you're going to use it, please let me know in the comment section down below. Otherwise, with all that being said, as always, thanks for watching, and I'll see you in the next video.